Hi there. Today in this video we are going to look at some basics of radicals. We want to look at some of the properties that are associated with them. We're going to look at how to simplify them, and we're going to also look at how to rationalize them. This is going to segue us into complex numbers when we talk about the letter I, which is really in truth a radical itself. So let's take a look at some of these things. Perhaps you'll remember them, and perhaps they will be a good refresher for you. All right, so the properties of exponents that we discussed previously also apply to radicals, because radicals are in truth a form of exponent. So what that means is if I have the square root of A and I multiply it by the square root of B, that means that the result will be the square root of A times B. And this is helpful for us when we are simplifying radicals, which we get to a little bit later. We can take this and break this apart. Very nice thing to know. This is also true with division. If I'm dealing with a quotient, if I have the square root of A and I divide that by the square root of B, it's really the same as the square root of the quotient A divided by B. And again, this can be helpful when we simplify radicals as well. And really, we often will go from here to here, and sometimes we go right back from here back to here to help us simplify things. So when we're talking about simplified radicals, we have no factors that are perfect squares if a radical is simplified. And if radicals are in a fraction, then they need to be simplified both individually and collectively as the fraction. Now, one might ask to themselves, I wonder what a number that is a perfect square is. And you know this, but perhaps you don't know the terminology. A number that's a perfect square is just a number that can be attained by multiplying a different number by itself, like 1 times 1, or 2 times 2. What's 2 times 2? That's 4, right? Or 3 times 3. And it's very good for you to become familiar with probably the list of all the perfect squares that are under 100 so that you can simplify things pretty quick. 49, 64, 81, and 100. Okay, of course, there's infinitely more of these numbers, but knowing these numbers are perfect squares will really help you out. Okay, so if I want to simplify something that looks like this, the square root of 125, we're going to come back to this idea, and we have something that is in this form that we want to break apart into this form. What I want to do is break it into two radicals, and I want to take the biggest perfect square factor of 125 out that I can, and I think that that's 25. And then I need to think, well, 25 times what would give me 125? Well, if I had quarters in my pocket and I knew I had $1.25, how many quarters would that be? That would be 5. Okay, so if I've done this correctly, then I take what's a perfect square and take it out of the radical. Make sure you take it out of the radical. And we end up with 5 radical 5 as our solution. Okay, how about this? If I want to simplify this expression, I have two things being multiplied together. Okay, well, I think what we're going to do here is we're going to first take them and put them together and then see if we can break them apart correctly. All right. So let's put these together. We can say that this is the same as, let's see, 5 times 10 is 50. X times x is x squared. Okay. Now I'm going to take this and break this into pieces with perfect squares and non-perfect squares. So let's think about what is the biggest perfect square that goes into 50. Looking at my list, I'll start with just less than 50 and work backwards. And 36 does not go into 50, but 25 does. So we're going to say 25. 25 times what gives me 50? That 2 goes into the other side, the non-perfect square radical. Now looking at this square root. X squared is a perfect square, so I'm going to put it in the perfect squares radical. Now the perfect square radical, I want to take that and take it out of the radical. So what is the square root of 25x squared? This is 5x and the square root of 2. Now, many textbooks will talk to you about we want our result here to always be positive. So many textbooks will say, truly we want to say that this is the absolute value of x. However, in the Pearson product and my math lab, they don't require the absolute value sign. So I wanted to address it for people who may not be using that product, but for my students, we are using that product, and you will not be required to put those absolute value bars in there. Okay, so this would be my answer. Okay, for this last example of this type, we are going to look at the square root of 150x cubed divided by the square root of 2x. There's a couple of different ways that you could do this correctly, and either one is viable. You could simplify the numerator and then divide it by this radical, or you could combine these into a single radical, divide them, and then simplify the result. And that's the way that I'm going to approach this problem. I'm going to take this whole thing and put it under a single radical. So 150x cubed divided by 2x. So I've taken these two radicals and put them into one. Now I'm going to take that fraction and divide the fraction. So 150 divided by 2 is 75, and the x cubed divided by x is x squared. Now I'm going to take that 75x squared that's under the radical, break it apart into two factors, one that includes all the perfect squares and one that does not. Okay, so I think that would kind of look like this. What's the biggest perfect square that goes into 75? Let's go backwards from 75. 64, no. 49, no. 36, no. 25, yes. So 25 goes in there how many times? It goes in there 3 times, and this is not a perfect square. Let's look at the x squared. X squared is a perfect square, so it goes under the perfect square radical. This can come out and become 5x square root of 3. Now, one thing to keep in mind is we've done a lot with taking the x squared out of the radical. What if instead of x squared, we had just like an x cubed under a square root? Well, we want to break this into the two radicals, one that's a perfect square, and then this is not the same as this, but what I have to multiply x squared by to get the x cubed. That's another x. Okay, so one of them's got to stay under the radical. Take this out of the radical, we'd have x square root of x, and then we'd be good to go. Okay, picking it up with addition and subtraction of radicals. We want to be able to combine radicals, but one of the cardinal rules about radicals is you can only combine like terms, which means you can only combine them if they have the same radicand or value that is underneath the radical. Okay, just like you cannot put 5x plus 7y together in one term, you can't put together 5 square root of 2 plus 7 square root of 3. These things must match if I want to combine them in any way. So sometimes we look out and we say, oh, we do have radicands that are the same. So I've got 7 of this radical 17, and I'm adding it to 19 of this radical 17. So I've got 7 of one thing and 19 of that same thing, then I can just put them together. And this is really just 7 plus 19 times the square root of 17, or 26 times the square root of 17. Okay, how about this one? Square root of 17x minus 20 times the square root of 17x. Okay, well, what do we have out here in front? This is really the same as 1. So I'm just subtracting 20 from 1. 1 minus 20, or negative 19 times the square root of 17x. All right. 7 times the square root of 3 plus the square root of 12. They don't have the same radicand. Does that mean I can't combine them? Not in the form they're in right now. But we do know that the square root of 12 can be simplified. Let's think about how does that work. The square root of 12, if I think about a factor that is a perfect square that goes into 12, and I know that to be 4, right? So 4 times 3 gives me 12. Take this out of the radical, and I've got 2 radical 3. Well, I had 7 radical 3 over here, and I'm just trying to add 2 radical 3 to it. So 7 plus 2, that's 9 of those radical 3's that I have all together. So the last topic that we're going to address in this video is how do you rationalize the denominator of an expression that has a radical in the denominator. We don't really care about radicals in the numerator, but it is convention that we don't want to have radicals in the denominator. And there's really 2 types of expressions that have radicals in the denominator. One of them has a single term. Okay, well let's go ahead and fill this in. Fractions, which include radicals, cannot have radical in the denominator. Right? Denominator. If the denominator only has one term, a monomial, you're going to multiply both the numerator and the denominator by the radical part of the denominator. Okay, so let's take a look at that. A and B are examples like that. If I have 15 divided by the square root of 6, to get that square root out of the denominator, I'm going to multiply both the top and the bottom by that radical. Okay? On the top, I just get 15 times the square root of 6 because I can only multiply radicals if they are both under the radical, right? So that 15 is not. Now the square root of 6 times the square root of 6. You can go the long way here and say, well, that's the square root of 36, which is 6. Or you can think about this in terms of what we're actually doing. When we multiply something by itself, it's the same as squaring it. So we're squaring a square root, which are, these two are inverse operations. So the squaring of the square root undoes the square root, and so we're only left with 6. Okay? So this is the answer, but it is not fully simplified. We want to look at what's outside the radical and think of it as a fraction that can be simplified. Notice that both of these have a factor of 3 that can come out, and then we end up with 5 times the square root of 6 over 2. If I divide out the 3 here, I get 5. If I divide out the 3 here, I get the 2. And this would be my final answer. Now in B, well, we are going to, there's a couple different ways we can do B. We can multiply by the square root of 12 over the square root of 12, or we can start by simplifying that first. And remember up here we simplified the square root of 12 to 2 radical 3. So this is the same as 6 over 2 radical 3. And using what we did just a second ago, right, we said we want to simplify this fraction. Well, isn't that the same as 3 over 1? It indeed is. So this is 3 over 1 times radical 3. Okay, so now this is a little bit simpler, and I can multiply both the top and the bottom by radical 3. And we end up with 3 radical 3 over the square root of 3 times the square root of 3 is the square root of 3 squared, which is just 3. And then again, I simplify this fraction, and 3 over 3 is 1. And so my final answer is just radical 3. Okay, so that's how we rationalize when there's a single term in the denominator. Now, when we have a binomial or a term that has a radical as only part of the denominator here, what we need to do is we multiply both the numerator and the denominator by the fancy word conjugate of the denominator. Now, the conjugate is just an expression that looks a lot like the initial expression, but the sign in the middle changes. So if I had 2 plus radical 3, the conjugate would be 2 minus radical 3. If I had 5 minus radical 2, the conjugate would be 5 plus radical 2. So in this case, I have 4 plus radical 5, and what I want to do is multiply both the top and the bottom by 4 minus radical 5. So I'm going to rewrite my initial problem here, and then I'm going to multiply the top by 4 minus radical 5 and the bottom by 4 minus radical 5. Okay? So on the top, I'm going to distribute that 8 to both pieces. And when I do that, I get 32 minus 8 radical 5. Outstanding. Now on the bottom, I'm going to multiply these two pieces together too. But it's a FOIL kind of case. I need to distribute the 4 through, and then I need to distribute the radical 5 through. But there is a shortcut if you recognize this pattern. If I ever have an a plus b times a minus b situation, I always end up with a squared minus b squared. Okay, so I can square the front, I can square the back, and put a minus in between. This is a really helpful and time-saving tip, because here this is what I have. I have a plus b, and then I've got the same thing here that's a minus b. That's the whole conjugate thing, right? So what I can do for the bottom is just square the front, and 4 times 4 is 16, and then put a minus in between and square the back. What is the square root of 5 squared? That's just 5. Okay? And then I would just finish this up by simplifying the denominator. I don't see anything else that can be done here. 32 minus 8 radical 5, all divided by 11. And that's all she wrote. That's all I wrote today. We'll see you next time.